Okay, question 44. So a chemist has to make a 100-gram sample of chlorobenzene C6H5Cl from the reaction. Now it tells us we want to make 100 grams of this one here, but the yield's only 65%. That means our equation isn't completely efficient. So there might be some left unreacted because it's not a very energetically favourable reaction, or there are some other losses or sources of error along the way. So 100 grams of this, we need to convert that to moles, but then we also need to take into account that it's only 65% efficient. So what we need to do first of all is work out moles. So this is the equation that we use. Rearrange that to find, using the molar mass, using our periodic table. So moles, 100 grams over. Now, C6, 12.01 times 6. Carbon, 5 hydrogens. And 1 chlorine. You have a molar mass of 112.56. Sorry about squeaky texture. Okay, so our moles of chlorobenzene is 0.888. 3 decimal places will be fine for that one. So that's our moles here in 100 grams, but we said it's only 65% efficient. So we need to aim to make more moles than that. When we put the reactants into the equation, we need to account for that. So the moles we need to make, if that was a 65% yield, we need to multiply this. So moles, I'll just write that we aim to make as moles of 65% yield multiplied by 100 over 65. Okay, so that will give us, so we take our moles here, I'll go with our rounded value, 0.888 multiplied by 100 over 65 means we need to actually aim to make 1.37 moles. So that's what we're looking to make. If we go back to our equation, so we wanted to make 1.37 moles here to be able to achieve 100 grams of it if it's only 65% efficient. Okay, now our ratio, we're looking, it's asking us the minimum quantity of benzene. So our ratio here, 1 mole of benzene gives us 1 mole of chlorobenzene. So that mole ratio is a nice easy one. That means we need to use 1.37 moles of chlorobenzene. Okay, so to finish the question, to determine the minimum quantity, we really should put that in mass because our question has used grams as our units. So I'm sorry, this is going to get a little bit messy on the whiteboard. Just going to continue in blue now for benzene. So our moles, I'll just put, I'm sorry, so that we can keep track of what we're using. C6H6, that's benzene. It goes 1.37. And now our mass of benzene equals moles times molar mass. So that equals 1.37 multiplied, now molar mass of benzene, 6 carbons and 6 hydrogens. So 78.12. That gives us 107. Now, what were our limiting? We had 3 significant figures to start with. So we'll just leave that as 107, and that's grams. So that's our moles, our moles multiplied by our molar mass gives us 107 grams is well, in fact, if we're going to be technical, even though we'd normally round down, if we want to be really sharp, if it's saying the minimum quantity of benzene used to achieve this, actually if we round down, we won't make our 100 grams of chlorobenzene, we'll make a tiny fraction less. So really, we should actually always round up when we're looking for a minimum quantity needed. So round up for a minimum. Oh, sorry, I'm really struggling to write on this small whiteboard. Okay, hopefully you've been able to follow that and it's not been too messy, and that's explain question 44.